Let's solve some more problems. Okay, so let's say we have d square minus 6d plus 9 y is equal to e to the power of 3x x square plus 7x plus 5. Okay, straightforward. Let's look at the auxiliary equation, that is m square minus 6m plus 9 equal to 0. This is straightforward. M minus 3 square equal to 0, which means m equal to 3 comma 3. So the complementary function would be c1 plus c2x e to the power of 3x. Now let's try to figure out the particular integral. So that we know is 1 by f of d, that is d square minus 6d plus 9 e to the power of 3x times x square plus 7x plus 5. Now here, if we directly substitute 3 into this, what will we get? 3 square is 9, 9 plus 9 is 18, minus 6 times 3 is 18, 18 minus 18, 0. So denominator will become 0. We don't want that. So let's do something else. Let's substitute d with d plus m. Yes. So then what happens? D plus 3 square minus 6d plus 3 plus 9 e to the power of 3x x square plus 7x plus 5. Let's expand all this. D square plus 6d plus 9 minus 6d minus 18 plus 9 e to the power of 3x x square plus 7x plus 5. Now here 60 and 60 cancels. 9 plus 9, 18 minus 18 gets cancelled. We are left with 1 by d square of e to the power of 3x x square plus 7x plus 5. Now this is e to the power of mx times v. Yes. So e to the power of 3x times 1 by d square of x square plus 7x plus 5. Remember, d square means we are talking of twice, right? And since it is in the denominator, we have to do integration and not differentiation. So let's say the first time when we do the integration, we get x cube by 3 plus 7x square by 2 plus 5x. Okay, now we have to do it again, integration. So we get what? 6 to the power of 4 by 4, that is 3 times 4 plus 7x cube by 2 times 3 plus 5x square by 2. Okay, so 3 e to the power of 3x times here 3 4 12, 3 to 6 and 2. So let's take 12 out. Okay, the idea of taking 12 out is we don't want anything in the denominator inside the brackets. So this becomes x to the power of 4 plus 7, 6 2 is 12, so 2, 14x cube plus 2 6 12, so 6 5 is 30x square. So now finally the solution is CF plus PI. CF is C1 plus C2x e to the power of 3x plus pi is e to the power of 3x by 12 times x to the power of 4 plus 14x cube plus 30x square. Okay, so that is a solution. Let's solve another problem. Let's say we have d square plus 4 times y is equal to sine 2x. So the auxiliary equation would be what? M square plus 4 equal to 0, which means m is equal to plus or minus 2i. So that means the complementary functions would be c1 cos 2x plus c2 sin 2x. Now we have to figure out the particular integral. Now for this, 1 by d square plus 4 times, and this sin 2x we will take it in this form, 1 by 2 times 1 minus cos 2x. Okay, so this is nothing but another way in which sin 2x can be written. Okay, so now this 1 by 2 can come out 2 times d square plus 4, and we can split it into two parts because of this. So minus 1 by 2 times d square plus 4 cos 2x. Yes, now here, since there is nothing there, d square plus 4, here there is nothing. What we can do is, nothing means we can take it as 1, and 1 can be represented as e to the power of 0x. Okay, minus, and this would become 2 times d square plus 2 square cos 2x. Now here this is m is equal to 0 or a equal to 0, so we can write this as 2 times 0 square plus 4 minus 1 by, this is in this particular form of 1 by d square plus 2 square, so which we can write it in the form of 1 by 2 x by 2a. Remember, so here 2 times 2 sine 2x, right? Remember, this is because previous sessions result that we had arrived at, 1 by d square plus a square cos ax is equal to x by 2a sine ax, right? So now what do we end up with? We end up with 1 by 8 minus 1 by 8 x sine 2x. And here we can take 1 by 8 out and write it as 1 minus x sine 2x. Yes, so our solution is going to be what? c1 cos 2x plus c2 sine 2x plus 1 by 8 minus, or let's take it in this form itself, 1 by 8 times 1 minus x sine 2x. So that is the solution. Okay, so here the tricky part is that sine 2x, you have to take it in this particular form. That is the tricky part. And second thing is, you have to remember this particular result which we derived in the previous session. Okay, let's take one more, and that is d cube minus 3d square plus 9d minus 27. Y is equal to cos 3x. Now auxiliary equation is going to be m cube minus 3m square plus 9m minus 27 equal to 0. And this can be split or factorized in this way: m minus 3 plus 9 times m minus 3 equal to 0. That is m square plus 9 times m minus 3 equal to 0, which means m is equal to 3 plus 3i minus 3i. So the complementary function would be c1 e to the power of 3x plus the conjugate pair would be c2 cos 3x plus c3 sin 3x. Okay, so that is the complementary function. Now we have to figure out the particular integral. Remember, this would be 1 by f of d, that is d cube minus 3d square plus 9d minus 27 cos 3x. Now this can be written as 1 by d square plus 9 times d minus 3 cos 3x. Now plus 9, we'll leave it as it is. So what we'll do is we'll multiply d minus 3 in the denominator by its conjugate, so d plus 3, which means in the numerator also we require d plus 3 cos 3x. Yes, so this becomes 1 by d square plus 9, in the numerator d plus 3, and here we have d square minus 9 cos 3x. Yes, this is what we wanted. So now 1 by d square plus 9 d plus 3. Now here what happens? Minus m square. D square can be replaced with or substituted with minus 3 square. So 1 by minus 3 square minus 9, which means minus 9 minus 9, which means 1 minus 18 cos 3x. Okay, so 1 minus 1 by 18, let's take it out. 1 by d square plus 9, and we end up with d plus 3 times cos 3x. And now what we'll do is we will distribute this d plus 3, right? So we will end up with d cos 3x plus 3 cos 3x minus 1 by 18 d square plus 9. D is nothing but dy by dx, right? So we differentiate cos 3x. We get what? Minus sin 3x and then plus 3 cos 3x. Okay. Now what is the next step? What we can do is we can take out this 3 and this 3, take it out, and then we can cancel this. So we are left with minus 1 by 6. Yes. D square plus 9. D square, and we can again distribute this. So we end up with 1 by d square plus 9 times sin 3x minus times minus. Okay, let's actually do the distribution here itself. Okay, so minus times minus becomes plus, then minus 1 by 6 d square plus 9 cos 3x. Or actually what we can do is take this 1 by 6 out. Yes, we can do something like this. And now if you look at this, this is d square plus a square sin 3x, the result that we developed, right? So which means we just have to apply that result. So which would be what? Minus x by 6. Okay, 6 is outside. 2 times 3 minus x by 2a. So 2a is going to be 3, because 9 should be written as 3 square. Similarly here also 9 should be written as 3 square. Okay, and this would become cos 3x minus 1 by, or let's not write 1, x by, in this case it is cos 3x, so x by 2 times 3 sin 3x. Now this becomes 6, this becomes 6, this we can take it out, so this becomes 6 6 36. This x and this x with the minus we can take it out, so minus x. So we are left with minus x by 36 times cos 3x plus sin 3x. Yes, this is our particular integral. So therefore our solution would be CF plus PI. So CF is what? CF is C1 E3x, C1 E3x plus C2 cos 3x plus C3 sin 3x. This is complementary function plus particular integral, that is minus x by 36 cos 3x plus sin 3x. So that is the solution. See, the result that we developed in the previous session becomes very useful here. We can immediately apply that. Anyhow, I think that's enough for today. Bye for now.